So I would suggest whenever you're given the quadratic trinomial, try to factor it with simpler methods, unless if you like the quadratic formula. The quadratic formula is rather rigorous, and it requires you to know a lot of little skills and to put them all together. To simplify things for you, remember that the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And note a few things. 1, the b is negative. 2, the square root goes over the entire rest of the equation. So don't just kind of end it right here. It goes all the way to the end. Be dramatic about it. 3, there's a minus in here. 4, there's a square. A lot of people forget the squared. Okay. And 5, it's 2a. Make sure that you have an a down there. And this fraction bar goes all the way across as well. Okay. And if we didn't mention the plus or minus, I'm going to mention it again. Plus or minus means that there's two possible answers. Now, the practicality of using this, I'm going to suggest that you practically use it as follows. Set it up with parentheses. So as far as what we're going to do in this class, you don't even have to think. All you got to do is, when you do a quadratic formula problem, set it up like that instantly. Just don't even think, just put it like that. Have the parentheses in place so that we can drop the values in. We begin by identifying the coefficients a, b, and c. A is a positive 1, b is a positive 2, c is a negative 5. We set up the blank quadratic formula. We plug in the appropriate value. So b is a positive 2 goes in here. B goes in here as well. 4a c over 2a. Following order of operations, we can simplify this. That's a negative 2 on the outside. 2 squared is a positive 4. Negative 4, positive 1, negative 5. If you multiply all three of those, it's a positive 20. And that's all over 2 times 1, which is 2. Now, if we simplify this further, we get that negative 2 plus or minus square root of 24 over 2. Now, we have to take a moment here to pause and look at this 24. And we have to factor that. Do a prime factorization tree. Because I can express 24 as 2 times 2 times 2 times 3. And you know you've seen this before from me. This is pre-algebra stuff. This is 7th grade stuff. But I want to remind you, we use this with complex numbers. We're using it again. We're going to use it again in the future. Just want to really drill this into you. We're looking for pairs. Here's a pair of 2's. So I'm going to pull that out. Everything else stays inside. So that's 2 times 3 is 6. So instead of square root of 24, I can put 2 radical 6. Now, if I split this up into two fractions, I can do that because they have the same denominator. We can reduce. 2 and 2 is a negative 1. And these 2's cancel out as well to give me a positive 1. And so these are the roots that I get. This is the answer to the problem. This is not the discriminant. This is the real answer. So there's no way you're going to get this from a tic-tac-toe or from the AC method or from any other simple method that I've taught you. This can only be found in this case through the quadratic formula. You could also find this through completing the square and other more complicated methods. So to be very clear, this is the answer. These are the roots. There's 2 of them, right? So technically the 2 roots are negative 1 plus radical 6 and negative 1 minus radical 6. Those are the 2 roots we got. They're not complex roots. I know there's a square root, but a square root doesn't make it complex. An imaginary number makes it complex. These are just 2 regular, different, real roots. That's how we do these problems. If you need to maybe pause and rewatch, retry, see what we did, it might be beneficial. We begin part B by identifying the coefficients A, B, and C. We set up the blank quadratic formula. We plug in the appropriate values. How do you know where they go, Mr. Robert? Well, that's what the formula is for. Go back to the front of the page of your notes, and you'll see the quadratic formula showing where the letters go where. I do order of operations first, so I'm going to take care of this first. That's a negative 1. 1 squared is 1. Negative 4 times 4 is negative 4 times negative 1 is positive 4. Put the fraction bar all the way across. 2 times 1 is 2. We simplify this, we get negative 1 plus or minus radical 5 over 2. Do we need to do a factor tree? We should, but it's 5. If you think about it, 5 just breaks down to 1 and 5. It's prime. So there's no perfect square of 5, and there's no factorization of it because it's prime. So we're pretty much done with this problem. Okay, these are the roots. There's 2 of them, right? Technically, the 2 roots are negative 1 plus radical 5 over 2 and negative 1 minus radical 5 over 2. Those are the 2 roots for this problem. Now, this one in particular has a special meaning. It's called the golden ratio. And you'd be quite fascinated to actually do a Google search, find out more about the golden ratio, especially if you're artistic or artsy or you just or sciencey. If you just are tired of math, Google search the golden ratio. It's pretty awesome. We identify A as positive 2, B as positive 1, C as positive 4. Remember, there is no X for the coefficient. It's just a positive 1. It's not a 0 because there is an X value there, so there's got to be 1 in front. We set up the blank. I know a lot of you have been kind of craving algebra that's just repetitive, and you're welcome. Here we are. However, we also need you to understand things like, when to take appropriate action, right? Do I separate? Do I pull out an imaginary number? Do I do prime factorization? So that falls on you. The beginning steps of all these problems for quadratic formulas are very mechanical, but then once you've done order of operations, that's where the thinking begins. So let's go ahead and plug in the appropriate values for this. Positive 2, positive 4, and it's positive 2 on the bottom. We simplify this, we get a negative 1. That's a 1 minus a 32 because it's 4, 2, 8, 4, 32. Most students have problems with working with these negatives and positives here, so you might want to spend some time on that. Bottom is positive 4. If I simplify that inside of that radical, I get a negative 31 over 4. Now, the 31 itself is prime. It doesn't have a perfect square, and if we do a factor tree, it doesn't quite do anything. It just 1 times 31. However, if we split this up, I get a negative 1 and I get a positive 31. And by definition of complex numbers, square root of negative 1 is equal to I. So instead of having this square root of negative 1 right here, I'm going to put I. That's an I, not a 2. So my final answer is negative 1 plus or minus I radical 31 over 4. Now, if we were doing discriminant, it would have told us that, hey, this problem has complex roots. And now we're showing you what that looks like. A complex root is one where there's an imaginary unit as part of the solution or part of the root. Remember, there's technically 2 answers here, right? There's technically a negative 1 plus I radical 31 over 4. That's a 31. And the other, that's horrible. And the other one is negative 1 minus I, that's an I, radical 31 over 4. Those are our 2 solutions for part C, and they are complex or imaginary roots. For this last one, we'll do the same setup. We'll plug in the appropriate values in their appropriate positions. We simplify, so it's a negative 4 on the outside. Plus or minus, that implies there's going to be 2 possible solutions. 4 squared is 16. This minus 4 times a positive 4 is negative 16, times a negative 1 is another positive 16. That gives me a negative 4 plus or minus radical 32 over 8. There is no perfect square for 32, but it is not prime, right? 4 times 8 is 32. 4 is 2 and 2. I circle my prime numbers. This is a good habit. 2 and 4. 4 is 2 times 2. So what I'm saying is that 32 is 2 times 2 times 2 times 2 times 2. And we're looking for pairs. So here's a pair of 2's, comes out. Here's a pair of 2's that comes out. And then this is not a pair of 2, it stays in there. So that's 2 times 2 on the outside is a 4. And the radical 2 is on the inside. In other words, what I'm saying is that instead of radical 32, I can replace that with 4 radical 2. And I can split this up into 2 fractions. We generally split this up into 2 fractions if I can reduce something somewhere. So you'll note that in B and C, I didn't separate into 2 fractions because there's nothing to reduce. In part A, I did that, and in part D, I am doing the same thing because I can reduce. So 4 into 8, well, that's a 1 and that's a 2. Same thing here, that's a 1 and that's a 2. And we can leave it like that, or if we want to put it back as a one denominator, we could. And that's our solution for this. Now, I'm going to warn some of you right now that like to go the easy route. You can definitely find online quadratic formula calculators. They're going to give you decimal values. I don't want decimal values in this class. I want the real solutions with the radicals and the fractions because those are precise. Okay, those are precise. Furthermore, I mean, you're free to use those things to help check your answers, but you know that I'm going to ask you about the process, about the setup to identify what went wrong, what went right. I'm more about the understanding than I am about the answers or the roots. So be careful with that. For your summary is actually going to be a problem that I want you to try out. So I'll give you this problem, okay? And I want you to use a discriminant to show that the roots are going to be a repeated double root. Okay, that's part 1. Then I want you to actually solve this formula. Solve this equation using the quadratic formula. And what you're going to see is when you do that, the stuff inside the square root cancels out. And so your square root disappears. And if it disappears, the plus or minus disappears. And then you just end up with like a number. And you're thinking, why don't I have 2 answers? Well, because the plus or minus disappeared. And because it's a repeated root. So take some time to do it. Work it out. And then use some time to spend in writing down words explaining what you did. Please don't skip it. It's pretty important.